Today we're going over 7-7 geometric sequences as exponential functions. So what a geometric sequence is it's a group of numbers that changes by the previous number being multiplied by a number, basically. That is the same thing every single time. So the number that's being multiplied is the same thing throughout the entire sequence of numbers, which would be the common ratio. So the common ratio is the number being multiplied. So here I want to know what's the difference between an arithmetic and a geometric sequence. So we just said geometric sequences. We're multiplying. And also remember that when you divide by a number, it's the same thing as multiplying by its reciprocal. So even if you're dividing, it's a geometric sequence. So multiplying or dividing. But multiplying is kind of what you say. And then an arithmetic sequence would then be adding or subtracting. So if a number is being added by the same thing each time, it's arithmetic. If the numbers are being multiplied by the same thing each time, it's geometric. So here we want to determine whether each sequence is arithmetic, geometric, or neither. So we need to figure out what is happening to each of these numbers every single time. So since we're working on geometric sequences, that's kind of what I'm going to check out first. So I'm going to do 256 divided by 128. And here it's being multiplied by 1/2 each time, because it's half of whatever that number is. So divided by 2, multiplied 1/2. Let's check again. 128 times 1/2, guess what? Is 64. 64 times 1/2 is 32. So this one is a geometric sequence, and the common ratio is 1/2. Here we go from 4 to 9. And that's multiplying by 2.25. Let's see if when we multiply 9 by 2.25, we come out with 20.25. So it's not multiplying. I know I'm adding 5. So let's see, 9 plus 12, or 9 plus 5, does not equal 12. So, that's not it either. This one's neither. It's not being added by a number consistently or being multiplied by a number consistently. Here it wants us to find the next 3 terms in each geometric sequence. So, to do that, we have to figure out what our common ratio is. So to get from 1 to -4, we know it's geometric, so we're multiplying by something. So what you multiply 1 by to get to -4 is -4. -4 times -4 is 16. 16 times -4 is -64. So then we're just going to go -64 times -4 is 256 times -4, and I'm literally just punching this into a calculator. So 256 times -4 is -1024. And then times -4 again to get us 4096. So those are the next 3 terms in my geometric sequence. And once again here, to get from 9 to 3, it's getting smaller, so it's going to be a fraction. I know that 9 divided by 3 is 3, which is the same thing as multiplying by 1/3. 3 times 1/3 is 1. 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9, because when you multiply numbers, you just multiply straight across. 1/9 times 1/3 is 1/27. And 1/27 times 1/3 is 1/81. All I had to do was multiply the denominator by 3 there. If I were to have gone and started just dividing by 3, I wouldn't have been able to pull these fractions out of that number, because I don't know what 1/81 looks like in a fraction. So make sure you kind of keep those in decimals, so it makes, in fractions, so that it makes a little more sense to you. Now, coming down to it, there can be a formula that you can create to describe and determine the next terms in your sequence. So if you want to figure out the a of n, so that's like the term of some number. So this is the term you want. So if you want the 5th term, it would be a to the 5th. Your a1 is the first number in the sequence. So in this case here, our a1 is 9, because that's the first number in the sequence. Your r is the common ratio, so what it's changing by each time, and it has to be in multiplication. So your common ratio. And then your n minus 1 is whatever number in the sequence you want. That's what the n stands for. And then it's minus 1. So if I wanted the 17th term in the sequence, it would be 17 minus 1. So I would be bringing it to the power of 16. So in this case, we want to write an equation for the nth term of the sequence. So we're going to need an equals a1 r n minus 1. So first things first, our a of n is what we want, so that can stay. Our a1 is the first number in our sequence, so that's -6. Now we need to figure out our common ratio. So to get from -6 to 12, I'm multiplying by -2. 12 times -2 gets us -24, and -24 times -2 gets us 48. So our common ratio is -2, and that is being brought to the power of n minus 1. Beautiful. If it told us it wants the a of 23, you would type into your calculator -6, -2, and then 23 minus 1 up here. So you would just replace the n with the number that you're looking for. And finally here we've got a word problem. It says the NCAA women's basketball tournament begins with 64 teams. That sounds kind of important. In each round, 1/2 of the teams are left to compete until only one team remains. Sketch a graph to represent how many teams are left in the round, and we're also going to create an equation for that. So our equation is an equals a1 r to the n minus 1. So first things first, our a1, we begin with 64 teams. Our ratio, it loses half each time. So 1/2 goes away, and then it's to the n minus 1. Our graph, it starts off big and drops and drops and drops until it goes like that. So here's our graph for you that's sketched. I just drew the shape, that's all I'm looking for. So you are off to work on your homework.